So in the second part of the lesson today, we're going to actually now look at where we have denominators that have variables in them. In every question in the first part, we always had not just numbers in the denominator. So if we look at this first example, 2 over x plus 7 over x minus 1 over x, we actually have all the same denominator here, so we don't have to really change anything. So all we have to do is add and subtract the numerators. So we get 2 plus 7, it gives us 9, and 9 minus 1 gives us 8. This is 8 over x. Now, the other thing they want us to do is they want us to determine the non-permissible values. Remember, those are the values we can never use for x. So since all the x's are denominators here, we know x cannot be 0. That's a restriction or a non-permissible value in this particular question. Second example we're going to look at is example C here. Now, again, we have a common denominator already. The common denominator is 3y minus 1. Now all we have to do is subtract the numerators. We get 3y minus 1 if we subtract the numerators. Well, if you have a binomial divided by itself, the answer when you simplify it is 1. We also need to determine the non-permissible values. So we have to take 3y minus 1 cannot equal 0. So 3y cannot equal 1. So y cannot equal 1/3. We just equate the denominator to 0 and solve for y. In this third example, we've got to be careful of this minus sign here, because that minus sign has to be applied to both of the terms in the second fraction. So we get 4x minus 2x, which is 2x, and 10 minus 4, which is 6. Now, if you look at this, at first glance you may think, oh, there's nothing I can simplify. But remember, one of the things you can do to simplify a binomial is you can remove a common factor. So here we have a common factor of 2. And if we divide each term by 2, 2x divided by 2 is x, 6 divided by 2 is 3, we actually get two binomials, one in the numerator, one in the denominator, that you can simplify. So in this case, these two terms cancel out, and we have a simplified answer of 2. Our restriction is x cannot equal negative 3, because if you equate x plus 3 cannot equal 0 and you subtract 3, that's going to give us our non-permissible value. So that wasn't too bad. Those denominators were the same, so we didn't have to do too much work. So now we're going to look at some questions where our denominators are not the same. We have to actually come up with a common denominator here. So if we look at the first question, 3 times 7 is 21, and we have a p in each denominator, so we'll leave that p in each denominator. So what did I have to multiply 3p by to get 21p? I had to multiply it by 7. So I have to do the same thing to the numerator. 7 times 5 is 35. 7p got multiplied by 3 to give me 21p, so I have to multiply the numerator by 3, and I get 6. So when I add this together, 35 plus 6 gives me 41 over 21p. And in this case, there is no number that divides evenly into 41 and 21, so that's our answer. But they also want us to look at the restrictions. So if I have 3p cannot equal 0 and I divide by 3, I still get p cannot equal 0 as a restriction. If I look at 7p cannot equal 0 and you divide by 7, you also get p cannot be equal to 0 as a restriction. Okay, let's look at this third example. In this third example, you're going to see 6x and 3x as our denominators. Well, if I just multiply 3x by 2, it gives me 6x. So now I have a common denominator of 6x. That means the first fraction, I don't have to change anything. The second fraction, I have to times by 2. So I get 2 times 3x is 6x. 2 times negative 2 is negative 4. But we have to remember that this negative is going to affect everything in that binomial in the numerator. So when we now start adding and subtracting, 2x minus 6x gives us negative 4x. Negative 5 minus a negative 4 is like negative 5 plus 4, which gives us -1. So this gives us this expression. The other thing they want us to do in this question is they want us to look at our restrictions. Now, if we look at this, 6x cannot equal 0, so if we divide by 6, x cannot equal 0. We're going to get the same thing if we use 3x also. So our restriction is x cannot be 0. All right, the last few examples are going to be a little more complex, but not a huge amount. We're going to try and expose you to some of the most common things that you're going to see. So in this particular example here, we've got a monomial of 2x and a binomial of x minus 4. So when we come up with our common denominators, we have to include the monomial and we have to include the binomial. Some people will say, well, Mr. Kaminsky, there's an x already in this monomial. Why do we have to include it here? Because this is a binomial, you have to include the whole thing. And if you look, there is nowhere else in any other denominator where we have the whole expression x minus 4. So we have to include that whole thing as part of our denominator. So what we're going to notice is that to get a denominator of 2x times x minus 4 in this first case, we have to multiply the numerator and the denominator by x minus 4. So we're multiplying this by x minus 4, so that gives us x minus 4 times x minus 9. In the second case, to make our denominators the same, we had to multiply the numerator and the denominator by 2x. So we're going to get 2x times 3x. So now, if you notice, you've got some terms that can be expanded in your numerator. So if I expand my numerator, and if you have to do that in on a scrap sheet of paper, go ahead and do that on a scrap sheet of paper. But you're going to get x squared minus 13x plus 36 when you expand that all over 2x times x minus 4. When we expand 2x times 3x, we're going to get 6x squared. Still over the same common denominator. So, if we now add and subtract like terms, 6x squared plus x squared is 7x squared minus 13x plus 36 all over 2x times x minus 4. Now the next thing you look at doing is seeing, can I factor this particular quadratic? I'll tell you in this case you can't. So that's as far as you can go. You cannot simplify 2x or x minus 4 into anything in the numerator, because you have to be able to simplify the entire trinomial. So this is our simplified answer, but they also want us to state restrictions. So if we look at 2x, and we say 2x cannot equal 0, well that means that x cannot equal 0. If we look at x minus 4 cannot equal 0, we get x cannot equal 4. So 0 and 4 are our two restrictions. All right, we're going to look at the example in part C now. You really, really have to be careful when you have questions that have negatives in them, because that negative applies to everything in that second fraction. So you really got to be cautious. In this case, we have two binomials, x minus 5 and x plus 1. So our common denominator involves both of those binomials. Now, I had to multiply the first denominator by x plus 1 to give us our common denominator. So I'm going to take my numerator and times it by x plus 1 also. In the second case, I had to multiply my denominator by x minus 5. So I'm going to multiply my numerator by x minus 5. And I'm going to put this in a set of square brackets, because when we expand this, we then have to apply this negative to all the terms inside the expansion. So if we go ahead and expand things, we're going to get 2x squared plus 3x plus 1. Remember, you can do that expansion of these two binomials in the numerator on a scrap sheet of paper. We still have our common denominator. If we expand our numerator now here, we have x squared minus 9x plus 20. All right, so now we're going to add and subtract things. So 2x squared minus x squared is going to leave us with x squared. 3x minus a negative 9x is going to give us positive 12x, because a negative and a negative is a positive. And 1 minus 20 gives us negative 19. And that's still all over x minus 5 and x plus 1. You cannot factor this. There are not two numbers that multiply to negative 19 and add to 12. The only things that multiply to negative 19 are 19 and 1, and there's no way to get that to add to 12. So here's our simplified form. We also have to state our non-permissible values. So in this particular question, x is not going to equal positive 5 and negative 1, because you just equate each of these to 0 and solve for x. So there we go. All right, let's look at our last example here. It has 3 fractions in it, and we have 3 different denominators. So what we have to do when we make up our common denominators here is our common denominators have to include the x plus 2, and the x plus 1, all 3 of those things. Okay, so if I compare my first denominator to what I have here, I multiplied this first denominator by x and x plus 1. So I have to take the 3, multiply it by x, and multiply it by x plus 1. Okay, in the second case, if we compare the denominator of x plus 1 to our common denominator, we multiplied our 2 in our numerator by x and by x plus 2. And finally, in the last case, our original denominator was just x, so we had to multiply our numerator by x plus 2 and x plus 1. So, if I start expanding things, 3x times x is 3x squared. 3x times 1 is 3x. Negative 2x times x is negative 2x squared, and negative 2x times 2 is negative 4x. And finally, if I expand this last numerator, I have 2 binomials that I need to expand. So when I distribute them, I get x squared plus 3x plus 2. So now I'm going to start adding and subtracting things. 3x squared minus 2x squared is 1, and 1x squared plus x squared gives me 2x squared. 3x minus 4x is negative 1x, and negative 1x plus 3x is positive 2x, and I have a lone whole number of positive 2 here. Now, I can factor this numerator. I can take out a common factor of 2, leaving me with x squared plus x plus 1. Now, there's nothing else I can do to factor this. This is in simplest form. I've factored it completely. They also want our non-permissible values. Well, if I look here, if I solve this for x, I'm going to get x cannot equal negative 2. If I solve this, I get x cannot equal negative 1, and if I solve that, I get x cannot equal 0. So there's our 3 non-permissible values. This is about the hardest question you're going to see today. There will be more difficult questions coming tomorrow, but for today, that's about the hardest one you're going to see.